In this tutorial, we will learn how to subset cases from a data frame object in R. So to get started, make sure you have a data file that you can read into R. In this case, it's a .csv or comma separated values file that we're working with here today. And my data file here is called personal data with a capital P and a capital D and no space between personal and data here. And as you can see, this just contains basic employee personal data or demographic data. Now, make sure that you save this file into a folder that you can subsequently reference and set as your working directory. And it'll make your life a little bit easier when you're working in R. And so in this case, I have saved this file into this folder that is my R workshop folder that lives within my H drive. You'll almost certainly have a different drive, a different folder and pathway to the folder that you have saved your data file in. In this case, again, mine happens to be my H drive R workshop folder here. And you can see that exact name of that data file here, personal data with a capital P and a capital D and comma separated values file format here. You can see that presented here within this folder. Okay, so the next thing we're going to do, we're going to come to RStudio here. You can see our console. Let's go ahead and just for aesthetic reasons, let's start with a blank slate, so to speak, and let's clear out the console by going to Edit, Clear Console. Alternatively, you could do Control and L if you're a Windows or PC user. All right, the next thing we're going to do is we're going to go to File, New File, and RScript. So that again is File, New File, and RScript to open up an RScript editor window. And this will allow us to track and make annotations and to create a single project or task for our script or our code so we can run it all at once when we start a new session. And this also makes things more reproducible as well. So I'm going to start off with a hashtag annotation here, which I really suggest that you get in the habit of using, is annotating your code, as it can make it easier for you to remember things when you come back to a session or a task, and it can be useful when you're working collaboratively with other people so they know what your thinking was and why you were doing certain things, or just what you were doing to begin with. So after, to the right of the hashtag, I'm going to make a note here and say that we are going to be subsetting cases from a data frame object. And that is our focus today. And we're doing it in R, or using the R programming language. So the first thing that we're going to do, and I'll work through these initial steps really quickly because they're covered in other tutorials, is we're going to set our working directory. My working directory folder, I know what that is off the top of my head, so I'm just going to do the setwd function all lowercase here, and as a sole parenthetical argument and within quotation marks, I'm going to type in the exact name of the path, which is the folder where that data file, that personal data file, CSV file is saved and where it lives. And so it happens to be my H drive, and my R workshop folder is where that file is saved on my computer here. And so if I highlight this line here, or I just click my cursor somewhere on the line and click run, I have set my working directory, and you see that confirmed here by looking at your console window, and I see my H drive R workshop folder has been set as my working directory. Alternatively, if you like drop downs, you can do session, set working directory, choose directory, find the folder where you save the data file. You'll see after you run that and find that folder and open it, you will see that you'll get the same command line. You'll get the same function down to your command line in your console here, and you can just copy and paste that into below whatever note you've made that indicates you've set your working directory. This just makes things faster when you start up each session. You don't have to do the drop downs every single time. All right, the next thing we're going to do is read in the data. And reading in data using the read.csv function is covered in another tutorial, so we won't get into much detail here. I'm just going to say that we're going to assign this data frame to an object that we can subsequently reference. And because what we're going to be reading in is personal data from employees, let's decide perhaps to call this object, or to name this object, personal data. Okay, so personal data all lowercase. You could call this object that we're naming here whatever you'd like, as long as it doesn't start with a numeral or a special character like a dash. And I'll use the left-handed arrow here to assign the data frame that we're going to be reading in to this object. And we're going to be using the read.csv function from base R, which means we don't need to install a separate package. And so it's read.csv all lowercase. And within the parentheses, as the sole parenthetical argument, type in quotation marks and the exact name of the data file, which happens to be personal data with a capital P and a capital D, no space. We saw that already when we looked at our folder that we set as our working directory folder. The exact name of that file is personal data with a capital P and a capital D. Okay, just make sure that you do add on that .csv extension here to tell the read.csv function that this file that you're reading in is in fact a comma separated values file. And so put your cursor somewhere on the line or highlight that whole line of code and click run. And now you can see blue text down here in our console. Everything seems to work out just fine here. And so let's take a look at the data, and we can either click on it here in our global environment, or we can switch things up, and I'm going to print it, the data frame object, to the console. And I'll just use the print function from base R, which is print all lowercase, and as a sole parenthetical argument, you can just copy and paste in the exact object name. In this case, it's a data frame object that we did assignment here using the left-handed arrow operator. We assigned our data frame to this object, which we decided to call personal data here, all lowercase. So just copy and paste that into the parentheses here of our print function, hit run, and you'll see down here in our console, we can view the whole data frame here, and it has 5 variables: ID, last name, first name, start date, and gender, and then 8 observations or cases, or in other words, 8 unique rows of data here, and these again correspond to employee personal information or data. Okay, the other thing that we're going to be doing here is we're going to determine the class of the variables. Another way of saying class is the type of the variables, or variable type. Okay, and this will come in handy because the type of data each variable contains will subsequently affect how we reference those with logical statements in the function we're going to be using today to subset cases from a data frame object. And I should make a note up here that another way of saying subsetting cases is filtering cases. Okay, so if you're subset filter, those terms can be used interchangeably. All right, so we're going to be using, to determine the class or the type of the variables in our data frame object, we'll use the str function, which is from base R, meaning we don't need to install a special package to access this function. It's str all lowercase, and just think str structure. It's the structure of our object. So I'm going to copy and paste in the exact name of our data frame object as the sole parenthetical argument. Put my cursor somewhere on that line and click run there. And you'll see we'll see that it's a data frame first of all, so that's the object type here. And then you'll see each of our variables, ID, last name, first name, start date, and gender. And to the right of them, you'll see the variable type or class. And so here you see the ID variable is of type int, which is integer, which is a special type of numeric data. And so when we look at this, we do see, the ID data are in fact all integers or numeric. And then all the other variables in our data frame object are of type character. Okay, and so character obviously is a special type it's a string type. In other words, it's text data here. It's non-numeric. And you can see that here visually. Note too that our start date variable, it did not read in as an actual variable type date. Instead, it read in as character. Okay, so this won't be understood as a date variable here. We would actually have to transform this variable to start date if we wanted to reference it as a date variable. Okay, so again, tuck this away because this is useful to know. Just remember that the ID variable is integer, which is a special type of numeric variable, and all the other variables are of type character. Okay, so now let's move on and let's start subsetting, or in other words, filtering. So we're going to subset that data frame by gender to start off with. And note that gender is one of the variable names here, gender all lowercase. And so the subset, let's start just with the function here. The subset function is subset all lowercase, okay? And we're going to be focusing on 2 different arguments in this subset function. The first argument we'll enter is the exact name of the data frame object, which I will paste in here. Okay, I previously copied that. It's personal data. So this tells the function which data frame object we're going to be referencing variables from and which data frame object we're going to be subsetting. Okay, the second argument, and remember we separate arguments by commas within function parentheses in R. The second argument is where we specify by first the name of the variable we wish to subset the data frame by. So in other words, the name of the variable that we wish to subset cases by in our data frame object. Okay? And that is gender. And so we can copy the exact name, and remember R is case sensitive here, the exact name of that data frame, or that variable, which is gender, all lowercase here. And in this case, let's make this more specific, and let's say subset by gender, and let's say woman, okay? So we will select just those cases for which the employee's gender identity is woman, okay? And so to do that, we'll use the equal operator, okay? So equal to operator. And so in R, the equal to operator is two equal signs side by side. Now to the right of the equal to operator, logical operator, we're going to put woman in quotation marks. And why do we need to put woman in quotation marks? Well, remember earlier when we ran that str, the structure function, to assess and evaluate what the variable types or classes were? We found that gender was of type character. Well, when you have a variable that's of type character, when you're using these logical statements like this in the subset function, you need to use quotation marks against the actual variable levels or categories or text that falls within that particular variable, that character variable, okay? So we can see woman here, and you can see it does this for us. When we actually ran the structure function, the str function, it actually put quotations around each of the observations for that variable and around the text, okay? So just make sure that when it's text, put the quotation marks around it. Okay, so watch what happens when we just run the function on its own here. You'll see it prints to our console. And so this can be useful in some circumstances. So we can see that there's just 3 employees that identify as a woman here as far as their gender identity. And so it just retained 3 cases from our original data frame that had 8 cases or observations. But what if we want to create a new data frame object that we can subsequently reference using the subset function? Well, we could overwrite the existing personal data frame object here. So I can just copy this and paste it to the left of our left-handed arrow operator. Remember, the left-handed arrow operator is what we use for variable assignment or assigning data to an object. And so anything that comes to the left of it, is to this left-handed arrow, is going to be what we're naming this data frame object. If I were to run this, it would just overwrite the existing personal data frame object, okay? But I want to, in this case, to practice, let's create an entirely new data frame object that we can reference subsequently and retain the original personal data frame object in our R global environment. And so to create a new data frame object, I'm just going to add a prefix here. You could do it any way you'd like, but I'm just going to do sub standing for subset in my mind. Okay. Now let's go ahead and run that line of code there. And if we come up here to our global environment, now you'll see a second data frame object. If we were to click on this and view it here in this tab, it's what we originally printed to our console, but now we have an object that has those data within it that we can subsequently reference. Okay. So there we go. So we have now subset the personal data frame object by the gender variable, and specifically we selected only those people where gender was equal to woman. Now you might be wondering, how do I know what these different logical operators are? Well, I'll give you a list of logical operators in R, okay? And to keep this quick and fast, I will just simply copy these and paste these in here. And I'll put hashtags in front of these to annotate them out. So just annotating these out so they don't, R doesn't attempt to run these if I were to run the whole script at once. All right, so as you can see here, we just use the equal to logical operator here. And again, it's 2 equal signs. But also you can see there's the traditional less than, greater than. Those should be fairly intuitive. But if you want to do less than equal to, it's the less than symbol followed by the equal sign, greater than equal to, greater than followed by the equal sign. If you want to say not equal to, which we'll practice next, exclamation point followed by equal. The exclamation point you can think of as indicating not when it's by itself. And when it's with equal, it means not equal to. And if we're talking about logical and logical or, a logical or is the vertical line here, and the logical and is the ampersand. So we'll practice with some of these to bring them to life a little bit more in just a second. Okay, so let's now practice using the not equal to logical operator here. So let's actually just copy these 2 lines of code right here. So I'm including the annotation, and I'm just going to paste them below here. And I'm going to note here, not equal to woman. So what we're going to do here is we're going to keep everything the same, even the name of the object that we're going to be creating here. So we're going to overwrite the existing sub underscore personal data, which is fine for our purposes here. And then we're going to change equal to exclamation equal to, as this says, subset the personal data frame object by the gender variable for cases not equal to woman. Okay, so in other words, this is going to remove all of those cases in our data frame or all those observations where gender is equal to woman. So watch what happens if we click run here. Okay, so now let's view that data frame object again. And now you can see what we've done, since there's just 2 levels to our gender variable in this particular case, man and woman. It's just removed the women, leaving only the men here. Okay. All right, so now let's practice subsetting by the ID variable. And why are we subsetting by the ID variable? Well, I'm doing that in this case because it's the only variable, if we scroll up here, that is of type integer or numeric, which means I can show you what it looks like when you don't need quotation marks around the level or the value of the variable. Okay, so let's go ahead and start by copying and pasting that line from above and just tweaking it. We'll just keep on overwriting this sub underscore personal data frame object. If you needed to create a new data frame object that you could have that's distinct from the existing ones, you could add a 2 to the end of this. You could just differ it in some way so it's not one of these 2 names if you don't wish to overwrite. Okay, so now we have our subset function as we used above. Same data frame object name, personal data, but this time we're going to change the second argument to be ID, which is the exact name of our ID variable, which is just ID all lowercase. And we're going to do, let's practice using greater than. Okay, so the greater than logical operator, which I showed you up here. That one's fairly intuitive. And let's take a look at our data frame object. Notice that we have IDs and range from 153 to 282 here. Let's just select those cases for which the ID variable number is greater than 154. So it'll select 155 all the way up to 282. All right. So let's type in 154 and note that when we don't put quotation marks around it, it'll be blue font here. And this is we don't put quotation marks here because the ID variable is of type integer. If it had been a type numeric, we would have done the same thing here. Okay, so let's click run here. Let's click on our global environment, our data frame object here. And so now we're focusing on the ID variable here. And just as I said it would, it has removed those first 2 rows that had the cases with IDs equal to 153 and 154. And because we said we wanted ID greater than 154, it selected 155 and up. And so it selected these 5 observations or cases here. Okay, so that illustrates how you can use an integer or numeric variable when you are filtering as well. So next, let's practice subsetting where we use the logical and the logical or, I should say. So I just copied these 2 lines from above so we can tweak them and adapt them. And so I'm going to say, let's say subset by gender or ID. Okay, so we're going to keep things the same, but just overwrite this sub underscore personal data frame object, which comes to the left of the left-handed arrow operator. Same function, subset. First argument remains the same, but this time before the ID, and it doesn't really matter when you're which order you put this in, but let's just type in since I put gender before ID in the annotation above. Let's do gender equals woman, followed by the logical OR operator. Okay, so this is the same as we were doing above, where gender is equal to woman. So we're saying, let's subset this data frame such that we keep all the cases where gender is equal to woman, or, and this is the logical OR operator, the vertical line here, or where ID is greater than 154. Okay, so let's click run here and see what happens. Let's click on our overwritten sub_personal data frame object here. And so now what you'll see is we have selected all those cases for where gender is equal to woman, or where the ID variable is greater than 154. And so you can see John Smith's ID variable is greater than 154, but John Smith's gender identity is man, and we retain that because one of those two statements was true. Okay, so that's what the logical OR is saying. One of these two statements needs to be true, but both don't need to be true for a case or an observation to be retained in the data frame object. Okay, so I'm going to copy this, and now we are going to paste it below, and let's practice thinking through the logical AND operator, which is represented by the ampersand. Okay, so actually I'll just type this out here as text to be consistent with the annotation above. So the logical and down here, instead of the logical OR operator, which is that vertical line, I'll put the ampersand, which is the logical AND. Okay, so watch what happens when we keep everything else the same. Now we're saying that both of these conditions, both of these logical arguments need to be met in order for a case to be retained. So a person needs to have gender equal to woman, and their ID number needs to be greater than 154. So that's how the logical AND operators works. Both of these statements need to be true. Okay, so let's click run there. Let's look at our updated data frame. You can see much smaller now because gender has to be equal to woman, and the ID variable has to be greater than 154, and that leaves 3 people that meet both of those conditions. Now, what if you wish to subset by a unique identifier? So specifically, let's imagine a situation where there's maybe 2 of these employees no longer work in the organization, and we want to remove those 2 specific people based on their unique identifier variable, which in this case is that ID variable. So to do that, we can use a slightly different approach here, but still using the subset function. So what we're going to do is, let's practice subsetting out IDs of 198 and 201, okay? And so 198 and 201, those were Linda Morales and Cindy Providence, okay? And so how are we going to do this? Well, let's start by copying and pasting one of these lines from above. So I'm just going to paste this one here. So we're going to still continue with the trend of overwriting this sub_personal data with the updated subset data frame data that we come up with here to the right of the left-handed arrow operator. Still using that subset function, still referencing the personal data frame object here. But now as the second argument, we're going to do something slightly different here. And what we're going to do is we're going to say ID, which is the name of that unique identifier variable, the exact name, lowercase ID. And then we're going to use a different type of operator called %in. So you can think of this as meaning within. So within C, which is our combine function. If you're not familiar with it, you can combine elements into a vector if you'd like using this function. And we're just going to list here in our vector the exact numbers of the unique identifier, which would be 198 and 201. Now note that these are because our ID variable, which we found out above, was of type integer. We don't put quotation marks around this. If our ID variable were of type character, then we would put quotation marks around each of these values, okay? So what this is doing is saying, by default here, it's saying subset this personal data frame object by ID where the values are within this vector here. So in other words, just select 198 and 201. Okay, so in this case, if we just leave it as is, we're just we're just selecting these two cases here. So watch what happens if I run this line as it is. And we go to our sub underscore personal data frame object that's been updated. You'll see we've only selected 198 and 201. Okay, so Linda Morales and Cindy Providence. We only selected those people with unique identifier or IDs equal to 198 and 201. But if you want to subset out those two specific individuals, you can put the not logical operator before ID. And so watch what happens now with that tweak. So I just ran it, click on the sub underscore personal data frame object, and now you can see the only cases that are missing are those that correspond to 198 and 201. Everybody else is retained, okay? So in other words, this is saying select the values that are not within this vector here, which would be 198 and 201, okay? All right, so moving right along here. Perhaps you don't want to use this within logical operator here, or this operator. Maybe it's hard to remember. It's something that just seems a little bit complicated. What the beauty of R is there's often this sense of equifinality that you can, if you want to subset out those people with IDs equal to 198 and 201, there's often multiple different ways we can get to the same end, okay? And so I'll show you how to do an equivalent approach, which is 2 steps here. And so what we're going to do is I'm just going to copy the first part of this, paste it below, okay? And as the second argument here, I'll add the other parenthesis here to close it out. I'm just going to use what we're more familiar with, which is the ID variable, which we already played around earlier with some simple subsetting or filtering. And I'll do not equal to, so exclamation point equal to, and you can always put spaces here if that's easier for you to read. I'll just put that there for illustration purposes. You could do it up here as well. Spaces don't matter in this case when it comes before or after these logical operators. And so we could start with the first step and say, well, let's, out of our original personal data frame object, let's just filter out or subset out that case where ID is equal to 198, okay? So in other words, we're saying what we want retained in our data frame object is everything except where ID is equal to 198, or in other words, when ID is not equal to 198, we retain everything else, okay? All right, so that's the first step here. So let's click run. So if we go to our sub underscore personal data frame object, you'll see that 198, the person with ID variable equal to 198, is now missing. Now as the second step, what we can do, let's just copy this line, paste it below, and then tweak it, is we are going to use this data frame object, sub underscore personal data, as input here by pasting it as the first argument here, input into the second subset object, a subset function, okay? And so what we're doing here is we're saying, well, first, based on the original data frame object, which was we called our personal data frame object, we removed case associated with ID 198, and then that created this new data frame object here, which we called sub underscore personal data, and then we use that data frame object, sub underscore personal data, as our first argument for our second subset function. And in this second subset function, this is where we're going to do ID is not equal to 201 in order to remove that second person, which had ID equal to 201. And we're going to then overwrite the existing sub underscore personal data frame object by just putting its name to the left of the left-handed arrow operator. So let's click run there. Okay, let's click on our sub underscore personal data frame object. And now you see both 198 and 201 are missing. Everybody else is retained. Okay, so this right here, these two steps, was equal to doing this single step here. Again, this is just meant to illustrate kind of the beauty of working with R, is that there's often different ways to get to the same end. Okay, so remember where earlier I said that the date variable, which the start date variable in this data frame object, so if we take a look at it, start date here, that when we looked at the structure of it by doing str, and I'll just put this down here in the console here to do this quickly. So I'll do our original data frame object, which is just personal data frame object, and hit enter there. Remember how I said that start date was of type character and not a variable type date? Well, that means it's going to be a problem if you want to subset or filter by that start date variable and if you want to treat it as a date. Now, dates can be really finicky and a little bit tricky to work with in R, so I'm going to walk through this relatively slowly to show you how you can actually first convert that start date variable to a variable of type date. So then subsequently you can use it as you would intuitively want to use it in the subset function. Okay, so we're going to first convert the character start date variable to the date type start date, and let's just create a new variable called start date 2 instead of overwriting the existing one. Okay, so first let's start with specifying this new start date variable. And so if you do the name of the data frame object, which is personal data in this case, and then follow it with the $ operator here, this means we can then attach and specify a specific variable from that data frame object. And so this is where we can specify, in this case, let's do start date 2 and put this to the left of a left-handed arrow operator here. And this just means that we're going to create a new variable and assign it to the personal data frame object. So it'll come and be attached to the end of this as a new column here. And we're doing so using the left-handed arrow. If we had just done start date by itself, it would overwrite the existing start date variable, which could be fine. But in this case, I just want to show you how to create a new variable here as well. All right, so the name of the function we're going to use is called as.date. And note that date is, the D in date is capitalized, okay, in this function. It's a base R function, which means we don't need to install a special package or an additional package to access it. The first argument, type in the name of the data frame object again, followed by that $ operator, and then followed by the specific variable we wish to convert to type date, okay, which is start date here. So that's the first argument, is all of this, okay? Have a comma, put in a comma to separate it from the second argument, which is where we specify the format we would like the date to be in. So let's do format equals, and a pretty conventional one, and I recommend just going with this by default, is within quotation, so format equals, and within quotation marks, do %m /%d %Y. So it's lowercase m, lowercase d, and capital Y here. Okay, and let's see if this runs. If not, we can tweak it a little bit to make it run. Okay, so let's run this here. Okay, if we click on our personal data frame object, now you see that we have a new variable here, and it's called start date 2, and you can see the format looks a little bit different here. This is usually a dead giveaway that it's actually in the date format. It's of type date that we wish to work with. Okay, now the little, if that hadn't have worked for you and you got an error message when doing that, it could be that you have some error in the syntax here, or it could be this. So I'm going to copy this and just put this here just in case this were to happen. If you put nest the as dot character function, and so essentially just nest personal data $ start date, that part within the as dot character, and then keep everything else the same and run, sometimes that will avoid some errors that you might come across. In this case, it was equivalent, okay? So again, all I did was just nest the name of the data frame, $, name of the specific variable that we wish to convert to a date, but I nested that within the as.character function, which converts to a character first. This was already of type character. Sometimes you might do this if it was of type factor or something like that. But in this case, we didn't need to do it, but I just show it here in case you did run into any kind of issues. So watch what happens now. So verify that the conversion worked. And I'm going to put a hashtag in front of this line here since we didn't actually need it. So it makes it a note rather than something that would run if we ran the script from start to finish. Okay, and so we'll use the str function again, which you can think of standing for a structure. and name of the data frame object, which is personal data that we added this new data frame or this new variable to, start date to. Click run. Okay, if now we come down here, we see the original start date variable was of type character. This new start date to variable we created is of type date. So we did the right thing. We're on the right track here. So let's finish this off by just doing a quick example of filtering by a variable that's of type date. So let's subset by start date to, which is that new variable we created. I'm just going to copy one of these lines from above as a template to start from, paste it below here. So since we added this variable to the personal data frame object, that's what we're referencing here as the first argument. And as the second argument, let's reference that start date variable, and it's start date to. And let's just say let's take a look here. Let's select all those people whose start date came after January 7th of 2016. So it'd be all these people down here, and it would remove those people who were January 7th and earlier. Okay? So what I'll do is I'll just copy, since we happen to have that value right there, I'll just do greater than. And with start dates, a little bit different. Often you need to do this, as.date. So to specify that the condition or the condition or the value that you're referencing, just make sure that you put it in quotation marks and put all of that within the as.date function, and as.date with a capital D. So we're just saying start date to, where it's greater than 2016-01-07, or in other words, January 7th, 2016. Click run, and we overwrote the existing sub_personal data frame object. Let's take a look there. Okay, so we've now jettisoned or removed those people that had start dates January 7th, 2016 or earlier. And we're left with these 5 people right here. All right, so this wraps up the tutorial where we learned how to subset or filter cases from a data frame object, and specifically we learned how to do so using the subset function, which comes from base R.